We're looking at variation of acceleration due to gravity with altitude. So this being the center of the Earth, this being on the surface of the Earth, if I happen to take a certain distance, say over here, point B. So what is the acceleration due to gravity at point B is what we are trying to understand. And by the way, these are dotted lines. This is passing through the center of the Earth. So it's coming out at point A and connecting. So I can take this height as h, this length as r, and we can get started off. So mass of the Earth is m. Let me not do that. So we will use the convention that we have acceleration due to gravity at point A is g, and this is gh. So we'll continue with this over here. Now, g on the surface of the Earth, that is something that we already know. So g is equal to gm by r square. Guys, it need not be Earth. It can be any planet per se. Anything, not only planet, anything. So let me make it as any planet. Okay. So this being the case, what we have next is gh. This is acceleration at an altitude. That is h meters above surface of the planet. So this is nothing but g times of m by r plus h the whole square. It's a simple straightforward expression. It works. So what our agenda is to express gh in terms of g. So our main thing is express gh in terms of g. That's what we are trying to, because g is something that we understand. If in place of planet, if we understand, take it as Earth, we experience g. Then we can relate it to g plus h. So what happens at that height? No, we can relate it. That's why we are trying to express in terms of g. That's the agenda. See guys, everything is relative. We understand by relating things, because our experience is what connects to the math over here. If not, this is the answer, honestly. There's nothing fancy over here. This is a straightforward answer. But what we are trying to do is connecting to something that we can relate to. Okay, so let's start with it. So one thing that we can directly do is, if I call this as 2 and 1. So I need to relate this to. So what can I do? It's a very simple, straightforward thing. So from 2, I can write, actually we can do many things. So I think this is easier for me. I can write gm, rewrite gm as small g r square. And then your gh will turn out to be, or let me change the color. Gh turns out to be g r square 1 by r plus h the whole square. A bit neater. And this further can be simplified. So that's what we are looking at. Okay, so this can be further simplified. So for that, let's consider the expression. Let's consider r square by r plus h the whole square. So first thing is, we're going to divide r square in both the numerator and denominator. So each term is getting divided by r square. So I'm taking the r square to each of this term. Since the entire square is there, I can do this. So this is a bit of a math. So if you guys are not very familiar with it, you should ask someone to explain this to you. It's simple exponent. And this can be further rewritten as 1 plus h by r to the power of minus 2. And to expand this, we are going to make use of, yes, binomial theorem using binomial theorem. So we have 1 plus minus 2c1 h by r, right, plus minus 3c2, 3c2, yeah, into h by r the whole square, plus so on and so forth. Okay, right? So it's the same thing. It's just that we are dealing with negative power. First term is minus 1 to the power of 1 to the power of minus 2. Technically it is so, but anyways, that's 1 only. And second term is going to be this, third term is this, and so on and so forth. So there are two things that we have to learn afresh. First thing is minus 2c1 being equal to minus 2. So this is equal to minus 2. But why is that? So whenever you deal with negative n, right, you need to use this directly. I have an example over here, but I'll take another example. It's much easier for me to explain from the scratch. See, whenever we have minus 6c3, you need to end with this expression, that is minus 6 in our case, minus 3 plus 1. So we need to end with minus 6 minus 3 plus 1. So this is basically minus 8. So minus 8, minus 7 and minus 6 will be part of the series. And this entire expression will be divided by 3 factorial. So you go the other way around, you know. So you can't use your traditional n factorial by n minus 1 factorial, r factorial. We can't do that. We have to use this directly. So traditionally this is how it's written, but my funda is start from the back, start with the last term and keep reducing, and technically keep increasing till you get the negative number needed. So this is minus 8, minus 7, minus 6. So this is minus 6, minus 5. So basically your 2 and 3, those determine what should be in the numerator. So since you have 2 factorial over here, we have 2 terms, 3 factorial, 3 terms. That's the pattern that you get to observe. Okay, so this is a bit of extra. But anyways, you just have to know that this term is minus 2. You don't have that explanation per se for your syllabus. It's for my satisfaction that I gave. Now, we have the term h by r. See, we know that h is not that big than r. It's quite small. Right? We're just talking about few hundreds of kilometers, for example, or few thousand kilometers. Right? Around 1000 kilometers, we can consider that we are around 1000 kilometers. Radius of the earth is quite bigger than this values, right? Few hundreds values, and if you take up, r is much bigger than that. So basically, h by r, right, from here we can infer that h by r will be a much smaller value than 1. The ratio will be much smaller than 1. So from this I can tell h by r to the power of any big power, right, high power, square or cube and all of that, will give us 0. So basically this term will be 0 and the remaining terms also will be 0. So this is 1, this is minus 2, and this is h by r. So basically this expression, therefore we finally have 1 minus 2 h by r. So all of this put together, what do we have? All of this put together, we have g of h is equal to g times of 1 minus 2h by r. And this is your answer. Okay. Yeah.